Flap trim compensation, as function of the flight guidance system, operates independently and automatically, irrespective of autopilot engagement. It is inhibited on the ground and at flap angles greater than 18 degrees. A failure is brought to the pilot's notice by two amber flight annunciators, one on the left and one on the right flight instrument panel. The Avro RJ is fitted with a two-stage stall warning and identification system. Two heated angle of attack sensor vanes, one on the left and one on the right side of the cockpit. Flap angle and airspeed are used to calculate how close the aircraft is to a stall condition. The first stage of stall detection is a so-called stall warning. At a predetermined angle of attack, resulting in a speed 5% above actual stall speed, both stick shaker motors, one on each column, operate. This is felt as vibration and can also be heard. Stall warning is signaled by two warn units. Each unit is connected to the opposite vane. One vane signaling a warning angle of attack is sufficient to produce a stall warning. The stall warning is available immediately after liftoff. During stick shaker operation, the ground proximity warning system will be inhibited, which is indicated at the central status panel by a white caption. When the angle of attack is further increased from a stall warning condition to an actual stall condition defined by a second predetermined angle of attack, a stick push powered by a pneumatic ram will force both control columns forward, which will reduce the angle of attack. Stick shakers and stick push operate as long as the relevant angle of attack persists. The stall identification is signaled by two identification units. Each unit is connected to its on-side vane. Note that the warn and ident units are connected in their respective channel. Channel 1, for example, will only signal a stick push if the left vane is at stall identification angle of attack and the right vane is at least at a warning angle of attack. This system design will prevent a stick push should one vane be mechanically jammed at an identification angle of attack. One channel, that means the ident unit and its associated warn unit, is sufficient to operate a stick push. Both stall valves will then be opened by either ident unit, which will allow bleed air from a reservoir fed directly from engines 2 and 3 to enter the stick push ram. This in turn pushes both columns forward. Stick shakers will be operating as long as the angle of attack is above their trigger point. The red stall valve A and B open. Flight annunciators are located on the left and right flight instrument panels next to the primary flight display. The whole stall identification system is available in flight 7 seconds after liftoff. If either identification unit detects an angle of attack greater than its trigger point and its associated warn unit has not operated, a stick push is not released, but the following warnings are given. An amber central warning panel caption, stall ident, and two amber flight annunciators, ident 1 or 2, on the left and right flight instrument panels. The faulty stall identification unit is then inhibited by pressing its ident push button. As soon as it's inhibited, inhib illuminates in the button and the system reverts to single channel operation. Reset is not possible in flight. The entire stall identification system can be inhibited at any time, for example, during an uncommanded stick push. In that case, push both buttons simultaneously. Ident 1 and 2 times inhib is then illuminated on the left and right flight instrument panel. Yaw control is provided by a hydraulically powered rudder. Two hydraulic actuators or power control units, PCUs, one of the green and one of the yellow system, are installed at the top of the fin and controlled by the two pairs of rudder pedals through a single cable control circuit. Normally, both actuators together move the rudder, but in case of a failure, a single actuator is able to control the rudder at a slower rate. Each actuator has a microswitch, which brings on the amber central warning panel rudder valve caption should one actuator stick mechanically. Additionally, on the ground, this caption is lit should one hydraulic system be at low pressure state. Artificial feel through the pilot's rudder pedal is by a spring strut, which increases the load on the pedal proportional to pedal travel. Note that the load is not increased with increasing speed. A Q limiter restricts the amount of rudder travel with increasing airspeed to prevent structural damage. The maximum value of rudder travel is 30 degrees right-left at or below 160 knots, linearly decreasing to 2 degrees right-left at 300 knots. A failure of the pitot-static supply to the Q-limiting system is indicated by an amber central warning panel rudder elevator Q fail caption. It is important to know that this failure could lead to structural damage to the aircraft as rudder movement might be up to 30 degrees, also at high speeds. The amber caption rudder limiter will come on below 160 knots, and if the Q limiter is still engaged, this in turn means that the full rudder deflection of 30 degrees will not be available at low speeds. No rudder trim tab is fitted. The rudder is hydraulically offset from neutral when trim is applied. For that, a trim wheel is fitted on the center console. Trim position is indicated in a window above. Trim is neutral when both the marker in the window and on the hand wheel are aligned. Trim has to be neutral for takeoff. Rudder trim is only available when the hydraulic systems are pressurized. The trim wheel operates two screw jacks. One repositions both actuators and in turn the rudder according to pilot's input via the trim wheel. The second screw jack is needed to recenter the rudder pedals as they would otherwise move away from the neutral with trim application. For that, the second screw jack repositions the Q limiter to neutral. Thereafter, a symmetric rudder travel along the new rudder datum is assured. The flaps are of the Fowler type and driven by screw jacks from a single drive shaft on each side. Each flap is not interrupted and extends from the wing root to the aileron. The drive shafts are driven by two hydraulic motors, one powered by the yellow and one powered by the green system. Each motor can drive both shafts, so flap travel, although at half speed, is available after single hydraulic system failure. The two motors are signaled electrically by the flap selector on the center console. The signal is routed via the flap computer in the avionics bay to the hydraulic motors, which apply internal brakes as soon as flap position matches the flap selector lever position. Flap position is confirmed on a flap position gauge powered by a central AC on the center panel. In case of failure of that gauge, for example, due to an electrical problem, flap position is indicated by markings on the inner pylon number 2. This marking cannot be seen from the cockpit. Five positions are selectable: up or 0, 18, 24, 30, and 33 degrees. The 18 and 24 degree position go-around flap settings are balked to aid their selection and to ensure the flap up or 0 and 33 are not selected inadvertently. Flap extension from 0 to 18 is limited to 205 knots on the RJ70, 215 knots on the RJ85, and 220 knots on the RJ100. However, mechanical balk prevents the flap lever from being pulled out at speeds greater than 227 knots. The pilot can override the balk by pressing the flap balk override button in an emergency situation or if the balk fails to release below 227 knots. The flap computer is comprised of two safety lanes and two control lanes. Control lane 1 controls the yellow hydraulic motor, control lane 2 the green hydraulic motor. Normally, both control lanes are operable and the flaps will run at normal speed. If one control lane fails, the entire flap system can be operated from a single control lane at half speed. Two safety lanes monitor operation of the system and provide fault protection. Safety Lane 1 provides protection against flap asymmetry and information for the flight recorder and the flap gauge. Safety Lane 2 is a monitor of both control lanes and able to shut both control lanes. A minor system degradation is indicated by an amber central warning panel caption, "Flap fault." Flaps are operative at half speed. Reasons for a flap fault are flap lever position does not match actual flap position, flap selections with one hydraulic